Alright, this video is going to give you an introduction to variables and data types, and so this is going to be a very important section here because variables, data types, declarations, assignments, all those things that we're going to be discussing, variable calls, will be involved in the rest of the semester in every section. So it's very important that we learn this, and there's going to be a lot of vocabulary here, but after chapter 2 some of the vocabulary starts to not be quite as much. So this is vocabulary that will be used throughout the semester, so this is going to be very important. So you should have your notes, chapter 2 notes, page 1 is where we're going to start, and you should also have another page which we're going to look at this point is this code. This is a program, as you can see, and we've got the class header and the main method header, and then we have a thing called declarations. So what's that? And you're starting to see int, total points, season. What is all that all about? And so this is what we're going to be taking a look at, and this is the kind of stuff that you're going to be writing as we move on. So we'll go back to the notes on page 1. So variables, the definition of a variable. That is a named storage location. That is a named storage location in the computer memory. And so the computer memory is the storage space in a computer. It's where digitally everything is stored in a computer. It's where data is processed. It's where the instructions for the programs, the instructions from the programs to the processor are kept. And it's divided, the computer memory is divided into a large number of small parts called cells. And so what happens as we look at this paper here, on your paper that has the code, what you should do is you should go ahead and make up some memory locations, storage locations, and a computer memory. So something like this you could do at the bottom of your page where there's more space, or you could do up here. And the idea here is that this is representing the computer memory here, and I'll do this often, and as we'll try to model what's going on in the computer with certain lines of code. Up to this point, the lines of code that we've been using have been print statements, so we see the output, we see the result. What's going to happen in a lot of statements now, a lot of stuff's going to be happening behind the scenes that will eventually affect the output. And so this is important to understand. This will help you write code better if you understand what the compiler is doing with certain types of lines of code. So you have a computer memory here, and I'm giving some space here. We're going to write some things in here, so give some space, but you should have at least 4 cells. Now the thing to understand is that in the computer memory you already have a bunch of cells. So cells are not created when we write code. The cells are already there. In fact, they're like storage locations, which is what a variable, we said a variable is. A variable is a named storage location in the computer memory. It's kind of like having drawers. When you, let's say you buy a dresser drawer and it has 4 drawers in it, and you haven't put anything in it, they're sitting there. So when you start putting your socks and sweatshirts and things inside of that dresser, it's not creating the drawers. The drawers are already there, and you're just electing to use certain drawers for certain things. And that's what's going on here. The thing to keep in mind is the computer memory is made up of many cells that are just sitting there that are waiting to be used and to store data. And so anyways, so let's go on back up here. So the purpose of variables. The purpose of variables is to store data that can be used later on in a program. The purpose of a variable is to store data that can be used in a program. Now, we talked about this previously when we went through the rental car facility. And if you remember, we had some parking spaces, and these parking spaces like this, and so we had some parking spaces that not necessarily all of them were filled. Actually, I did not mean to have this be filled with anything. We had one filled. So we had many parking spaces, but what we did is we said we're going to store the car, a certain car in here. And this car, let's say, was a Ford Focus. So we don't store the car in there to sit there forever. And so it's stored there so somebody knows where to get it, and then it can be used. And the same thing, you put your socks in a drawer, not to sit there forever, but so that you can use it later. And that's exactly what happens with variables. Now, how do you name a variable? Remember, when we named classes, which is the only other thing that we've named so far, we started with the capital letter, and we used upper camel casing, and so we had things like what this says. So we had capital S, it's season, points, calculation. Each word was capitalized. Well, the variables are very similar, and however, you start with a lowercase letter. So start with a lowercase letter, and that sets up the difference right there between capital or classes and variables. Also, it's not the the compiler does not have a problem with whether you capitalize the beginning letter or not. It's just what we call conventional way of naming variables and naming classes. So most programmers will start their variables with a lowercase and start their class names with capital letters. We want to use lower camel casing, and all that means is let's say that we had a class, we would name it total pay, and so it starts with a capital letter. If we were going to name a variable the same name, we would go total pay. So we're still using camel casing. In other words, every word is capitalized at its first letter. But the only difference is the lower camel casing means it starts with a lowercase letter instead of an uppercase letter. It's the only difference. Number 3, we want the names of variables to be as short as you can make them and still fulfill what we're going to say in number 4. So we don't want real long variable names. We want to try to keep them as short as we can. In my example here, total points game, second half points, total point. Now see, this I probably should have made tote points season to try to keep it as short as I could. And so sometimes it's very difficult to come up with a short name, so you just do the best you can. Now the next thing is very important. We want our variables to have descriptive names. They need to be descriptive. They need to relate to the data that's being stored. They need to relate to the data that is being stored. So, for instance, in our rental car facility, our data types were compact or economy, and then midsize, and then SUV. So it's compact because we're going to store compact cars in here. So the data type needs to relate to what you're going to store in there. And so that's what happens here. Did I say data type? The variable. The variable is A1. This is not a good example here. I shouldn't have done that. I should go up here. So if you say 8 and it's in a variable named first half points, well, that makes sense because the person, or somebody scored 8 points in the first half. Now if you just said points, that may not be descriptive enough. 8 points, maybe you need more description than that, and in this case we might need to, because you're going to distinguish between first half and second half points, and you're going to distinguish between total points for the season and total points for the game. So you can't just use points. It's not going to be descriptive enough in this type of a program. And so as we go on here, that's variable. So variables is storage location, just like a parking space is a storage for cars, just like your drawers are storage for your clothes, things like that. Let's see. Data types. Now the data type of a variable, must match the data being stored in its storage location. So once again, the name of your variable needs to relate to the data that's being stored in there, and your data type needs to be. So the data type of a variable must match the data being stored in the storage location. So let's go back to what I was really trying to say here earlier in the car rental example that we started out with before, is that we said these are going to be compacts, this is going to be mid-size, this is going to be for SUVs. And so we made this a compact type because we want to park compact cars in it. So if you imagine trying to put an SUV, a longer, bigger car into a smaller parking space, that's going to be an issue. So that's kind of the idea there. And so the int is one of the data types that we're going to use. And just think of int as being abbreviation for integer in math. So integer, which is positive or negative whole numbers. So I probably should have put this in parentheses instead, like that. So an int means integers. So we're looking at positive and negative whole numbers, no decimals. And then a double is for decimals. So the double is a data type for a storage location that will store decimals. And then a string is a data type for a storage location that's going to store words. So you could type in here, or you could write in here words, and then you could also put in here groups of characters. So a string is a group of characters. And remember, characters are the letters, the upper and lower case. They're symbols, punctuation marks, spaces are considered to be a character. And so all those things are part of a string, and that's what the string data type holds. And so going back to our car rental facility, here we had compact. Well, we have an int, we might have a double, and so we're going to store decimals in here. Here you have string. We're going to store strings in here. And so these are types of data that is going to be used in each particular different storage location. So let's go back to here. So data types determine the type. I'm sorry, not the type. Data types determine the size of cell used to store data. It determines the size of the cell that's being used to store the data. It's the size or how much it can store. So not all data types are going to be able to or require the same amount of storage space. So in fact, the main thing here is that doubles are larger than ints. A double is larger than an int. A decimal will require more memory or more storage than an int does. And so in here you might say an int is smaller, and so it's going to take up less space, and then a double is going to take up the most space. So you will need a larger cell, or a cell that can store the most in it would be for here. So that's kind of the idea. And so this way, if you try to type a decimal in the int storage location, you would see it wouldn't fit, just like the SUV wouldn't fit in the compact parking spot. Okay, so let's go on to here. Okay, there are other types of data types that we're not necessarily going to be using, but just to make note of it, the integer data types include byte, and then there's a thing called there's a byte, there's a short, that's a data type, an int, as we talked about already, and then a long. Those are all int data types. Then there's some what we call floating point data types, which variables or data types which relate to decimals. So there's a data type called a float, and there's a data type, of course, that we know of is called a double. The double is takes the longest, is the more precise decimal, so because it can be longer. So that's basically how that goes. So these are the main, these are primitive, what they call primitive data types, which we'll talk about at another time as far as why they're called primitive. So that's the idea there. So let's go ahead and get rid of that. Let's see. Declaring a variable. Okay, this is very, 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 very important when we talk about declaring variables. You're going to be declaring variables from here till the end of the semester. And so declaring a variable is this. It's defining the name and data type. I gotta get rid of this E. The name and data type of a variable. And you may declare the data type of a variable only once. So if we look at the code, you'll see in line 8 this has or is a declaration. And so what we see here is we have a data type that we already talked about, and this is the name of the storage location or the name of the variable, where before we had something like Ford Focus, and then we named the parking spot A1. Okay, so that's what's going on here. Now this is a declaration, and the compiler does something with this, and it's behind the scenes, so we don't actually see it take place. We just see the result of it. And so here's the compiler's actions. We'll write them down and we'll illustrate it. So a compiler reserves and names a storage location. Okay, so it reserves and names a storage location as first half points. It gives it that name. This is all done in the computer memory, and that's important because it's happening in your computer physically, and it's to store decimals. It's set up to store, integers, because it's an int. So it reserves and names a storage location as first half points in the computer memory. It sets it up to store integers, whole numbers, ints. And so this is what happens, and this is what you should write down as I go through this. So what you want to do is when the computer sees line 8, it sees a data type and it sees a name, and it goes, okay, I need to go to the computer memory and reserve a cell. Just like you're hungry, you want to go to the restaurant, you call the restaurant and you want to reserve a table. Okay, and that's what's happening here. And so the compiler goes into the computer memory, and remember there's tons and tons of cells, and so one of these is picked to be the storage location for this particular variable. And so what happens is it names this variable as first half or total points season. So what you can do is go ahead and write that above your cell. And I'm abbreviating because I don't have room in here. So total points season. And it's set up to be an int. Remember we said that it determines the size, how much it can hold. And so this particular storage location is named total point season, and it's the size, or it's large enough to hold, or it's set up to hold an int or integers. And so then what we could do is we could go on to the next one and go int first half points. Well, you could do the same thing. It's going to reserve. In fact, what we'll do is we'll just go like this. So each of these is going to be a different declaration, and they're all going to be ints. And so line 9 does the second one. Line 10, the compiler will go over to computer memory, reserve this cell, reserve a cell, give it a name, set it up to handle ints and to store ints, and then you have the final one, which is total points gained, which is set up to hold ints as well. So you could write those in. You got those set up. We'll use those more actually tomorrow, but we're going to get started with them. So this is what's happening in the computer memory when the compiler sees these cells or this code. Okay, so let's move on. And so declaration number 2. Now, remember, a declaration is the data type and the variable name. And so the declaration of the next one, here's a declaration, but it's got more than a declaration in this declaration or in this statement. Let me see here. So it's got the data type and the variable name, and then it's got something else to it. And so we'll talk about that here in a second. Okay, so here's the data type, the variable name, and then what it's going to do, it says equals 8. Now what you really do, this is really what happens. This is really means it's assigned 8. So this part here means assigned 8. This part here is the declaration. And so, oops, let's see, I'm going to pause for just a second. Okay, so what we have here is this part here, int first half points, is the declaration part of it. Then the equal sign in 8, this is actually called an assignment operator, is assigned 8. That is the assignment or the initialization. And so that's when a storage location is given something to store. So it's given, that's its value being assigned to it. So in our rental facility, we assigned A1 to store Ford Focus, and that's what it's storing. Now this one would be a different car and so forth. So that is the idea. Compiler's action. What does it do with this line of code? Well, what it does is it does what it did in the first part where you had int first half points. So this part here is the same, so I'm not having to fill any blanks in there. Does the same thing, goes into the computer memory, reserves and names a storage location set up to handle ints. And then what it does is it stores an 8 in the storage location. It actually puts it in there, just like parking the Focus in the A1. We're parking the 8 inside of first half point storage location. It's like putting 3 pairs of socks in your sock drawer. And here the variable is initialized. So we say that the variable is initialized, which is also, well, which is really initialization down here. Initialization is a special type of assignment. And so it is initialized because it's given its value. The variable is given its value when it is declared. So when it's declared on the same line, when it's assigned a value on the same line as declared, we say it's been initialized, because initial refers to the first. For instance, your initials are the first letter of your first and last name. So it's first, and that's the first value. Okay, so that's as far as we went on this day 3 of this week, and so we will stop right here.